Okay, Mr. Benson here with the second part. So this is the level 8.5 questions. So firstly, write a formula which will help you work out the gradient of a straight line. Now, this is something that should be really fundamental because basically what it's saying is, how do we calculate the gradient? So there's two ways you could answer this one. So it's basically, what's the definition of gradient? So firstly, gradient equals rise over run. So this is the definition of gradient. It's not the best answer for how you actually calculate it though. So a better answer would be probably this formula, m equals y2 minus y1 over x2 minus x1. Oops, forgot my one. Okay, so that's the best answer for that question. Moving on, question 7. So the gradient for the following diagram is. So this is asking you to do what you just described in the previous question. Now again, this one was kind of disappointingly badly done. So again, two ways to think about it. One is, let's think about the run. Well, the run is how much we go across, or the rise and the run, sorry. So in fact, let's think about the rise first. So the rise is how much we go up from, well, any 2 points really. So I'm going to choose this point here and this point here because I know exactly where they are because they're on the axes and they're, you know, clearly going through those points. So I can see that I've gone from 0 to 5. So my rise in this case, so rise equals 5. From here I've gone from -2 across to 0. Now remember, when you're doing your run, always make it go from left to right. So I've got a run of 2. So one way of doing this is just to go, the gradient is rise over run, which is 5 over 2, and that's your answer. Now if you want to be a little bit more fancy about this one, you can think about it in terms of the coordinates. Now this one here, it's 0 on the x-axis and 5 on the y-axis, so that point is at 0, 5. The point down here is at -2, 0. Now if I was going to call these x1, y1 and x2, y2, now I'm going to go from left to right, so this is x1, y1, and this has got to be x2, y2. Okay, so all I'm going to do is use my formula. So it is, remember, y2 minus y1 over x2 minus x1. This should be on in your bound reference. So all I've got to do is carefully put the numbers in. Now this is where people go wrong, but there's no reason to get it wrong if you're careful. y2 goes here. y2 in this case is 5. y1 is next. Now in this case that's a deformed 0, but it's definitely meant to be 0. x2 is 0. Now another source of errors here, so it's a minus. Now x1 is -2, so I've got to have minus minus. Now the tricky bit here, and this is where people often struggle with directed numbers, is that a negative is a positive. So what we get here is 5 minus 0, it's just 5 over 0 plus 2, and that again just equals 5 over 2. So either way you do it, you get the same answer of 5 over 2. Okay, going on to the next question. The rule for a line whose gradient is 2 and y-intercept is -7 is. Now, so the gradient is m, the y-intercept is c. Now the standard form for an equation is y equals mx plus c. So if we replace m with 2 and c with -7, now remember that a plus and a minus is just a minus, so it all ends up as y equals 2x minus 7. So this is D. Question 9. Now find the x and y intercepts of the following line. Now the form is in the x and y intercept form, so it's not in the y equals mx plus c form. It's in the form where we've got the y and x values on the same side of the equation. So what we need to do here is use the x and y intercept method to do that. Now I'm going to split my page in half here. This is the way I like to do it, but you don't have to do it this way. Now to find I'll start off with the x-intercept. all I need to do is let y equals 0, because you've got to remember that the x-intercept happens on the x-axis, and that's where y equals 0. So all I do is I replace my y with the value 0. Now you can see that all that's left is one value that we don't know, which is the value of x. So I can now solve to find x. Now 3 zeros is 0, so I'm left with minus 2x equals minus 15. Then I'm just going to solve. Now to solve this, I've got to do the opposite operation to whatever is currently happening to the x. Now it's being multiplied by minus 2, so I'm going to divide both sides by minus 2. Now, you don't have to show this step if you can do it in your head, but I'm just showing you what we're doing mathematically. Now, remember, minus 2 over minus 2 cancels, leaving us with x. Now, this is kind of an annoying one because it is an improper fraction. There's no really nice way of writing this one, or you've either got to write it as a fraction or a decimal. But the negative signs cancel here, so so minus divided by minus gives us a plus, and 15 divided by 2, you could write 7.5 or 7.5 or something like that. Okay, to find the y-intercept, we just do the opposite substitution, but we do exactly the same process. So there's nothing fancy here in terms of the math. So we're going to let x equal 0. So 3y minus 2 times 0 equals negative 15. So 3y, now minus 2 times 0 is 0, so this whole term just vanishes and we're left with this. Same thing that we did previously. To get the y by itself, I'm dividing by this coefficient here. So to get, it's currently y multiplied by 3, so the opposite operation is to divide by 3 on both sides. The 3's cancel on the left hand side, and I'm left with y equals negative 5. So those are my two intercepts. Now remember, this is not the x and y values for a coordinate, but it in fact is telling us 2 points on the graph. It's telling us that the x-intercept is at 7.5, which let's say that's about there, and the y-intercept is at negative 5, which would be something like that. So that's what we found. Okay, question 10. We've got a table of values, and the question we're asked is which rule corresponds to the table of values, or the other way around. Now, there's a couple of ways you can think about this one. Now, I'm going to start off with what I think is obvious. One thing to think about here with all of these equations is they're all in this form y equals mx plus c. Now, we know that c is the y-intercept. Now, and the y-intercept happens when x equals 0. So if we look up here, what we can find is that our y-intercept is given in this ordered pair here. So when x is 0, y equals minus 1. So we know that our equation is something along the lines of y equals mx minus 1. Now, that immediately eliminates e, so e can't be right. Now, what we need to think about next is what is our gradient doing on this graph? So how is our y value changing as our x value changes? The easiest thing to do here is just to look when we go from 0 to 1 on the x-axis, what happens to the y? Now, y is going from negative 1 to negative 3, which means it's changing by negative 2. So when we have a run of plus 1 going from 0 to 1, we've got a rise of negative 2, and so our gradient must equal negative 2 over 1, which is of course negative 2. So our equation is y equals minus 2x minus 1, and so our answer here has got to be C. Question 11, which ordered pair is a solution to minus 3x plus 2y equals 12? Now this is an 8.75 question, so it's getting a little bit harder and more towards what you need, or the final things that you need to master to have the year 9 sort of, or the level 9 standard. Okay, so a solution means the values that make that equation true. Now at the moment we've got 3x plus 2y equals 12, so if we substitute an x value into and a y value into this, then our left hand side of the equation should also equal 12. Now I'm just going to now when I look at this, I can see that I've got a negative coefficient at the front and a positive coefficient for the y. Now what this means is that if both my x values and my y values were negative, or positive rather, sorry, what I'm going to end up with is a number that's actually fairly small. So when I look at these, most of my options are, pretty close to each other, so they're 2 or 3 or 3 or 2 or something like that. Now if they were both positive numbers, like in part A, I know without really thinking about it too much that the left hand side is definitely not going to equal 12. Now I can show you that by substituting those numbers in. So minus 3 times 2 plus 2 times 3. Now what does that equal? Well, it's minus 6 plus 6, which equals 0. So that doesn't make the equation true, so it's not a solution. So what I'm so there are two ways I could go through this one. I could just go through and substitute each pair, but you can actually narrow it down a bit first. I know that I'm probably going to want a negative x value and a positive y value in order to get 12, which is a relatively big number when you compare it to the numbers that we're looking at. So I reckon that it's probably not going to be D or E for the same reason as A, so I'm just going to get rid of that one. D I don't think is likely because they're both negative numbers. So we're down to B or C. Okay, with B, well, if I substitute that one in, so B, minus 3 plus 2 times 2. Okay, negative 3 times negative 3 is plus 9, plus 4 is 13. So close but no cigar, as they say. So we're actually only left with C, but we can also show that that does work. So minus 3 times minus 2 plus 2 times positive 3 equals, so minus 3 times minus 2 is plus 6, 2 times 3 is 6, and this equals 12. So C is our correct answer for question 11.